Okay, well, thank you very much, everybody, for coming to our session. It's great to see so many people here today. So this session's called Biomanufacturing, Scaling the Sustainable Bioeconomy. So let me firstly introduce myself. My name is Professor Ian O'Hara. I'm a professor in bioeconomy from Queensland University of Technology in Brisbane, Australia, where I also represent and support the Queensland Government in growing the Queensland bioeconomy and developing bioeconomy strategies and solutions for Australia. So as we all know, the world is facing some serious challenges as the population continues to increase. We need more food to support a growing population. We need more energy to support global development. We extract and consume in a linear economy, and we are literally drowning in waste. And our society is resulting in climate change and environmental degradation. So in this context, biomanufacturing of sustainable low-carbon products based on renewable biological feedstocks offers opportunities to reduce our usage of fossil fuels, create sustainable agricultural industries and regional economies, and fulfil consumer demand for sustainable solutions. However, there are significant challenges in cost, competition with existing industries, market demand, and innovation capacity. How do we overcome these challenges to realise the potential benefits in sustainability, health and nutrition, and consumer choice? In this session, we'll be addressing these challenges and others to find a path to realising global impact and achieve the benefits and promise of biomanufacturing. So we have a truly impressive list of speakers for the roundtable here today. With me on the panel, we have Siobhan Costa, who's the CEO of Eclipse Ingredients, a company developing technology to produce human lactoferrin milk proteins. Dr. Denise Villagomez, a senior lecturer from University of Queensland, who is an expert in the biomining of critical minerals. Professor Claudia Vickers from Queensland University of Technology, a well-recognised expert in synthetic biology, and Professor Volker Sieber from the Technical University of Munich, who is also a global expert in bioeconomy and runs the Global Bioeconomy Alliance. We will also be looking for contributions from the audience, so please get your questions ready, and we look forward to you engaging in this panel session also. So let's get into it. So we're going to start with Siobhan. Let's start with what biomanufacturing can do for people and planet. Siobhan, tell us about Eclipse and what you were doing.
Yes, so hi, as Ian mentioned, I am the founder and CEO of Eclipse Ingredients. We are a biotech startup based in Brisbane, Australia. We spun out of Australia's National Science Agency, CSIRO, at the start of this year, and we have raised source funding of up to nearly 10 million Australian. This is from both venture capital and also significant non-dilutive funding from the Australian government through various support programs, grants and R&D tax rebates. Our focus is on sustainably creating ingredients that have incredible health properties from yeast instead of animals using precision fermentation. We are starting with human lactoferrin, as Ian mentioned, and this is an incredible protein that is found in breast milk and immune cells. It has an array of amazing functionality, from supporting the immune system and microbiome to iron regulation, anti-inflammatory properties, antimicrobial properties, to name a few. At the moment, we rely on cow's milk to source this amazing protein, and it takes 10,000 litres of cow's milk to make 1 kilogram. So it's extremely unsustainable. It's quite scarce in cow's milk, and it's very difficult to scale. So if we reflect on what this would look like if we were to increase production by just 2,000 tonnes, it would take 20 billion litres of milk and increase carbon emissions by 45 million tonnes. So this is an environmental impossibility. It's something we just cannot do using traditional methods. So bring in precision fermentation, where we can, create these ingredients from yeast instead of from animals. It means that we can do this with between 90 to 99% fewer carbon emissions and less land and water use. So it's truly remarkable. And more than that, there's a problem with the cow protein. It's different to what we naturally make. So there's a 30% difference in its amino acid structure. And with precision fermentation, we get to make the human version. So the same as what we biologically, are designed and what we recognise. So this is really, huge, I suppose, in terms of our ability to impact both people health, but also the planetary health. So I think that's what the promise of biomanufacturing is offering, is that we don't need to compromise planet health for human health. We can achieve both.
Oh, that's fabulous. It's so exciting to really be at that cutting edge of technology, but actually delivering on the promise of people and planet from biomanufacturing. So Denise, you work in biomining of critical minerals. What does biomining offer in terms of supporting people and planet?
Yeah, first I'm going to explain what biomining is. Biomining is the use of microorganisms and bio-based materials to extract critical minerals from several sources, but the target here is unconventional sources, such as mining waste and even electronic waste. And I'm going to explain first what is a critical mineral. So everybody has a smartphone, and this phone has some components, elements that are defined as critical minerals because they are not only used on phones, but they are used in advanced technologies and also on renewable energy technologies. So the criticality reflects not only the economics related to it, but also the supply risk and the geopolitical risks. So by looking at unconventional sources for extracting these critical minerals, we also enhance the circular economy. And we also can make sources that were in the past seen as uneconomically feasible, now a source that can be a business case. So as I say to you, we use microorganisms and we use them in different ways. The reason why we think and has been demonstrated that is more sustainable is because it reduces the amount of reagents or chemicals that are used. It operates at milder conditions, which means that it requires lower energy and lower water, up to 40%, for example, for water needs. And also it generates less amounts of hazardous waste and water pollution. So with all these components, we're also talking about enhancing circular economy by using by recycling materials from something that is considered waste. My research focuses on extracting critical minerals from acid mine drainage, which is the second environmental challenge after climate change, and also from other waste, mining waste, such as red mud tailings. Red mud tailings is a hazardous waste that is stockpiled all over the planet in billions of tons, that also contains significant amounts of rare elements, such as dysprosium and cerium. And these elements are used in electric vehicles, solar panels, and wind turbines. So this is something that it's very important in the quest for the decarbonization of the planet. We produce organic acids that target or that extract these rare elements, and we also produce biomaterials such as metal binding proteins that can be used as ion exchange resins, so we can recover these elements. Yeah.
Good. So, there's reduction. So the use of biological processes, you can reduce water, you can reduce the energy requirements, you can see significant reduction in waste. These are amazing opportunities. we'll get to some of the challenges of doing this in a few minutes.
Definitely, yes.
So Claudia, these are really two great examples, one around biomanufacturing, one around biomining. And this all relies or is based on synthetic biology or engineering biology to really generate solutions. So where are we at in the commercialisation of engineering biology? How's the field progressing? Where are we up to?
Yeah, a really important question. So first I'll give a little more colour to my background. So as Ian said, I'm a professor at Queensland University of Technology, but I'm not a sort of normal ivory tower academic professor. I've spent quite a bit of time in government R&D, a couple of years in startup companies, finding out what it's really like at the coal face of getting technologies out into the real world. And I also run a consulting company that works with startup companies and venture capital and provides due diligence and helps with developing R&D programs that'll deliver on the commercial objectives of the company. So I've got a bit more of a perhaps broader perspective than, I guess, someone who's been all their life in academia. And I think it's been mentioned a few times already today, is the concept of the Gartner hype cycle. So with any kind of technology innovation trigger, you go through a process where there's this peak of inflated expectations where you are promising everything with this technology. You can solve every problem that the world has to be solved. And then reality hits and you go into the trough of disillusionment. And it can hit pretty hard. And then after the trough of disillusionment, then you enter the slope of enlightenment, where you have a much more realistic vision or understanding of what you can and can't do with that technology. And ultimately, you get the plateau of productivity happening. And 2024, I think, was when we really hit the trough of disillusionment in the synthetic biology, precision fermentation technology process. And we saw that evidence with the collapse of a lot of several really high-profile companies that had really been leading the field in doing commercialisation of synthetic biology and precision fermentation technologies. And at the moment, it's really hard to raise in that environment where there's a lot of uncertainty about what the technology can and can't do. And I think Siobhan's just done an amazing job with Eclipse getting that off the ground, and certainly in the current environment. But it's actually a very promising time to be, I think, in the synthetic biology trajectory, because we know what we can do and we know what we can't do. We know that we can make high-value pharmaceuticals, flavours, fragrances, ingredients. We can make money out of that because we need them at relatively low yields. So we can deliver on that. There's a business model for that. But the products that will really shift the needle on sustainability, bulk chemicals and fuels in particular, those are the ones we really struggle to get to. And those promises to make those products that will give us access to a $9 trillion global bulk chemicals and fuel market, and also will deliver 20 to 80% fewer greenhouse gas emissions and help decarbonise those very hard to decarbonise markets. They're the ones that are very, very hard to get to, and they're the ones that underpin enormous private and public investment into synthetic biology as a technology. So it's an interesting time, it's a challenging time right now, but I actually think an optimistic time, because there's a better understanding and a better ability to do due diligence on what we can and can't do.
So disillusionment, enlightenment, the opportunities are growing. Volker, bring you into the conversation as well. You're based here in Europe. What are you seeing from a European perspective, or perhaps from your connections internationally? In terms of bioeconomy, are you seeing these same challenges around getting to scale? Are you seeing those opportunities still emerging?
Well, let's first look at the state that we are in Europe. We have a very dense population. We have a very long-standing, highly developed industry, old industry, relying on fossil resources. On the other hand, you have the awareness here in Europe. European Union sees themselves as a forerunner in going towards sustainability. And it's all on the political agendas. So there is a willingness to change, and it has been early on happening by funding, for example, biomanufacturing of biofuels with subsidies, which can be debated about. But at the end, it's all about fighting the climate change. On the other hand, there are other issues like biodiversity loss, and so there are no easy solutions. And the idea is that we in Europe should benefit from these new technologies, from synthetic biology, and from making food, microbial food, by that reducing our footprint, so the ecological footprint on this planet. And as I said, Europe, we are quite many people, so it will be a strong effect. On the other hand, we have to look on where are the resources coming from. And in Europe, we do rely on resources from countries which are maybe more rich in resources. Lots of land
Like
in
Australia.
like Australia, lots of land to grow biomass in the tropics, very good. But certainly also lots of land to have wind power or solar fuel. And it is about bringing these together, because when you are like in Europe, requiring the energy to come from outside, you have to partner with those that have it. And coming back to the original question, so what can bioeconomy and biomanufacturing do here? So the potential is really there. It's a change from the fossil to the renewable resources. That's what manufacturing allows, and that's what we need. And that where Europe can benefit with the market, with the people's awareness that things have to change, and where the rest of the world can also benefit by supplying into this market and altogether then developing new technologies.
So there's this incredible promise of biomanufacturing and bioeconomy. I mean, I think one of the stats says that the bioeconomy could be a third of total global economy by 2050. It's a massive ramp up. It's an incredible opportunity. And you've all mentioned those opportunities in different ways and in different sectors. But we're having challenges in scaling bioeconomy. We're having challenges in scaling biomanufacturing. And when we talk about scaling, we're not just talking about the engineering challenge, although that clearly is one, but the challenges of scaling regulation and policy and human capability and all of these other things. So what do each of you see as the biggest challenges that we need to address for your company or for your industry in scaling the sector? Let's start with you, Siobhan.
Yes, I think from an innovation perspective and from a startup perspective, obviously this technology has a very long development cycle, and so it takes quite a long time to get it to market, and then regulations that you need to get through increase that time even further. And then on top of that, very specialised equipment, infrastructure and skills are needed in order to get this technology to market. So that all means it's very expensive. It's not something that can be bootstrapped as a startup. So you really do need capital. We need millions of dollars in order to get a product to market. But then we face the challenge as startups where investors, and rightly so, aren't necessarily willing or able to wait a really long time to get that product to market, nor are they wanting to invest in a technology that hasn't yet been de-risked, so that we haven't got a technology prototype for, that we haven't got the market validation, that we haven't got regulatory clarity. So all these risk factors, but that, I guess the catch-22, really tough catch-22 for a startup is that you need money to create that prototype and de-risk, but then you need that prototype to raise money. So I think that's one of the really big challenges for innovation in this space, personally.
So there's money and there's time and there's a sufficient runway to get to a point where your technology can
get a return on investment, start generating revenue, get that market traction that you need. It's very different to a SaaS company where you can bootstrap, maybe a couple $100,000, you could remortgage your home. I don't have a multi-million-dollar home to mortgage. Yeah.
Great. Thanks, Siobhan. So, Denise, what about in biomining? What do you see as being the biggest challenges for your sector?
Well, I think one of the biggest challenges is the trust and the acceptance from the industry. So the mining industry is a very conventional industry in the sense that adopting new technologies is difficult for them. And I think what is important is the push that we have, or the opportunity that we have now for proposing new technologies, because they also are under pressure in terms of decreasing the emissions and meeting the carbon emissions by 2050, and also supplying the critical minerals in this case that they need to supply for the decarbonization of the planet. So that has been a push for accepting or willing to accept new technologies. Even though biomining has been around for many years, when we talk about the extraction of copper, for example, it's been decades as an established technology. And in a lesser extent for the extraction of gold. But when we're talking about extraction from unconventional sources and extraction of elements that were not extracted before, then new challenges come up. And I think that it's very important to, we will come up with some recommendations, but I'm thinking just going in advance that building trust is something that is key. And is one of the biggest challenges.
Yeah, and I think in very traditional sectors like mining and the cost of the capital that goes into any new development, the same in biomanufacturing, the cost of the capital that goes in means that you've got to really de-risk to a point which is very different to other technologies or other industries that may be more capital light. So really interesting insights. Claudia, synthetic biology, more broadly, what are the challenges that we're seeing in really getting synthetic biology to scale?
Yeah, so scalability is a real challenge. And I think with bulk products and biofuels, which is where we can really shift the needle on sustainability, the challenge is that you're competing with what's a waste product from the petrochemical industry. So in a barrel of oil, the petrochemical industry is making their money from the top 10 or 20%. That's where the fine chemicals come from. The rest of it is a waste product, and if we didn't burn it in our cars, then it would cost them an absolute fortune to dispose of that waste product. So you're trying to compete in that kind of environment. And there are two major challenges in there. So one is getting the rate, yield and titer of the process high enough. That's an engineering challenge, and it's a fixable challenge. It takes time and effort. But then there's the scaling, going from 100 mils in a flask in the lab to 100,000 kiloliters that you need to be doing it at that kind of scale in order to produce the amount that you need to be effectively competing in the market. And in our industry, what we've been doing is focusing on the opposite for a long time. So miniaturization so that we can do high throughput assays and testing to find the right combination to get the rate, yield and titer up. But the problem is that cells don't behave the same way in a shake flask in the lab as they do in a massive bioreactor out in the real world. So in that case, you really need to get to scale as quickly as possible. So the faster you can get into a pilot facility, the better. So access to pilot facilities is really important in the scaling process, and getting there quickly is really important.
And then also, I think, just making that decision point on when you do start scaling up, about what titer is adequate for you to then go to that next step, because it's also it doesn't make sense to scale up if you're not economically viable at the titer that you're at in the lab.
Yep, running the calculations effectively, doing a techno-economic analysis that tells you, okay, I need to get to here, and then I scale.
Yeah.
But then you also need regulation to be at that same speed as well, because you're sort of running, companies like Siobhan, you're running to meet a deadline to get your technology through, but then we've got regulatory systems that are not scaled to respond in the same manner. Volker, what are you seeing as well in terms of the challenges from your perspective?
Oh, they are certainly manifold, and we've heard quite a good summary already. So it's about the processes, the plants, pilot plants for upscaling. It's about the people as well. But taking up what Claudia said, the problem of the biomanufacturing, the product that you want to produce, are fighting basically against existing fossil-based in price on the market. And while you can really make a difference by having something bio-based that has carbon dioxide taken out of the air in a product that is, as a material, really helping decarbonization, you still can't get it sold because there is no premium to it. In Europe, subsidies have really pushed the biofuels for many decades, and that's an existing market, but it's kept alive by subsidies or by some kind of support. And we need to have the carbon source somewhat priced in. Like if you take plant material or even carbon dioxide being removed out of the air, carbon capture, then there has to be a premium in the product, and that will start a market. And as soon as you have a market and can sell a product, then companies are more willing to invest. And this has to be a regulation which should not change in 2 years or in few months, because politicians get scared of the economy crisis. So there has to be some really steadiness in those decisions. On the other hand, what we heard about is the scaling up. We have actually in Europe quite a good number of pilot plants where you can go from the 5 liter, 100 liter, 1000 liter up to 100 cubic meter almost. That's already production, 100 cubic meter. And they're more built, like at Technical University of Munich, in our bioeconomy site in Straubing, currently this 30 cubic meter pilot plant constructed from the synthetic biology, from the microliter or actually picoliter that Claudia said, up to the many cubic meters in one side, where then people and companies can come in and really bridge that gap. And there are funding schemes also to support renting these pilot plants that should help the startup then to get over this valley of death that you have at the beginning. And so it's really manifold. Then you need the people to run these plants. Education has to continue with that progress. I mean, there are many study courses, and they're well received in Straubing. At Munich, we have many international biotechnology students, many different courses, and we see that there is the willingness all over the world to educate in that. And I don't think there will be a shortage, because that can be helped quite easily. But there are many challenges that have to be worked on. Some are worked on quite efficiently. Others, we still need a bit more to push.
And I think another one is the regulations as well, in terms of getting the products to market, which kind of touched on a little bit. There's very long regulatory timelines to get novel ingredients into food products. So even if we have a product ready to go, so we're ready to actually sell that product to the market, we then have to wait at least in Australia and Singapore 12 to 18 months before we have regulatory approval. And I know here in Europe with EFSA, it's even longer.
That's what I said. You'll be lucky with just 12 months. So, new food regulation is really a terrible thing. And we have this cost action, European-funded cost action, where this is just the topic of. So many scientists come together on microbial food and regulation and accelerating regulation. How to address that? That is so important.
And it's a tough. I get it. We want our products to be safe. We want to make sure they're safe. But we also, I think, need really clear frameworks that allow startups to have that de-risking component to give back to investors to say, this is the pathway, this is how we get it to market, and this is likely how long it's going to take.
Great. So we've really captured a broad range of issues there. We've talked about capital. We've talked about industry capacity, really, and industry capability to adopt technology. We've talked about regulation and policy, and then the consumer aspects as well. So lots of things. But it's easier to talk about challenges, regardless of. We have to accept that these challenges exist. And I guess we need to think about what are the pathways through, because if we want to see the benefit of this technology resulting in benefits to people and planet, we need to work out how to get through these challenges despite them existing. So what are the pathways, do you think, that we have to actually really capture the benefits despite all these challenges? Siobhan?
I think Eclipse is actually a really great example, to be honest. So lots of things were in our favour. Our incubation period in CSIRO, Australia's National Science Agency, meant that we got to de-risk this technology without private investment. So we got to create prototypes, demonstrate functionality, demonstrate market demand, work out the unit economics, prove that there was a pathway to viability, and also get clarity on the regulatory pathway and how we got the product to market. On top of that, non-dilutive funding, hugely important. So about 60% of our funding has come from non-dilutive sources in Australia, which is, I'm really grateful to be there. We have an incredibly supportive ecosystem in Australia, and those programs have also then enabled partnerships. So we have partnerships with the Queensland University of Technology, QUT, and the University of Queensland and CSIRO to scale up our tech. So that means we get access to world-class infrastructure and equipment and skills to really rapidly get our technology to market. So I think for Eclipse, that's been really important in terms of being able to build this, better, faster, way more efficiently. And then the flip side of that is that we can raise at really reasonable valuations, which is hugely important in this market because it means that we have room to grow into our valuations. So we haven't had to raise as much money in capital, so that meant that our cap table is going to be much more attractive in the long term, which I think for Eclipse puts us in a really strong position.
No, that's fabulous and a great example of the importance of really considering your financing structures and the support mechanisms you have around you. I forgot to mention that very shortly we're going to be coming to the audience for questions, so please get your questions ready and we'll be with you in a minute. So Denise, what about you? What do you see the opportunities? Where do you see the pathways to get through this mix of challenges?
I think something that was mentioned here, and I think is very important, is the support from government or the role of the government on facilitating or putting pathways for funding, where that can help build trust from industry and also from several parties. So I think in my side, Queensland government has been key on having a strategy towards critical mineral recovery or extracting minerals from waste, and those pathways also help the companies to feel trust on the pathways and also on that there's going to be a technology in the future that can be applied. The other opportunity I think that Volker mentioned briefly was education, and I think this the new generations and the fact that there are more and more people educated in the bio-based space going into industry is something that is opening opportunities, and we can clearly see, like the industry partners that we currently have some background on biotechnology, and that's great because now we have a common language to talk to, and that, as I said, open opportunities. There is something also that we will see in the near future, as we have seen on chemical-based processes, where there are some established processes that are well known by industry and they trust. And I can see in the near future bio-based processes that are well known in books, thought and understood even by operators. So that can also help to build and to open more opportunities for the development or the implementation of technologies. Yeah.
So success breeds success, and success demonstrates a way forward for other companies. Claudia.
Yeah, so I guess I want to reinforce a couple of things that have come up already. So when I was working in CSIRO, we had what's called a Pathways to Impact framework, where you are considering the social, legal, ethical, institutional considerations around the technology that you're developing. You're considering need, you're considering social license to operate. So the program that I ran there in Australia's National Research Organisation, CSIRO, included not just biophysical sciences but also social sciences, and we had quite a large sort of $4 million investment into the social science side of the program, and that helped a lot to break down barriers and help our scientists to better understand what the broader pathway to getting out into the real world looked like from the social science perspective. So I think that's very important. Another thing that came up was taking advantages of opportunities for non-dilutive funding, and there are a broad variety of opportunities, sort of no matter where you are, but in particular in Australia we have this amazing R&D tax incentive system where 42 cents for every dollar that you spend is going to come back for you in the tax system, and that's transformative. You can do almost twice as much research with that kind of incentive that's going on. So running fast, running lean, being hungry, I think is really important. And then there is something that's really critical, which is proper analysis of the opportunity that exists. So I've sort of pivoted in the last several years to focusing more on my science portfolio on what we can meaningfully do about climate change. And in fact, if you sit down and do a full techno-economic analysis, not many people can do that, but you don't have to do that. You can do something very simple called a Fermi analysis, which is a back-of-the-envelope calculation using reasonable, unchallengeable assumptions and determine whether the technology that you're using is going to deliver what you say it's going to deliver in the best possible scenario, if it's scaling and effective. So we've just actually released a framework that includes Fermi analysis and consideration of social, legal, ethical opportunities, workforce availability and such forth, that you can apply to determine whether you can actually meaningfully get to the impact that you want to get. In our case, it was what sort of bio-based interventions can meaningfully deliver the scale of carbon dioxide emissions reduction to actually impact on climate change. So really putting numbers, quantitatively analysing what you can actually do with your technology rather than just going, oh, we're going to get a 90% reduction because precision fermentation says we're going to get that and everybody says that, and I don't know where the numbers came from, but it sounds really good to me, right? So really understanding what you can do and whether or not you can deliver what you say you can deliver. And the upside of that is that venture capital companies, they have that understanding now. So you're not going to get funded if you're making unreasonable promises now, because guess what? We're on that slope of enlightenment now.
Great. Really good insights. Volker, pathways to overcoming the challenges.
Well, many things were said already. It's about cooperation between industry and academia. It's about social sciences to really look at not just the market, but how would people react, taking people along. And so what should be added to that is all these inclusions and cooperations should be not just locally, it should be internationally. It's kind of fragmenting currently, with many nations kind of looking only at their own good. So to counteract that, and we have to counteract that, climate is global. We have founded this Global Bioeconomy Alliance many years ago, where the leading universities all over the world, like in Queensland, in Germany, in Munich, South America, are come together and making progress and going for impact for specific topics like sustainable mining, using biomass from the ocean and other liquid cellulose waste materials, many topics that will make a change in biomanufacturing, in bioeconomy, and always looking at the social impacts and what also the benefit for the regions is. So we work closely together with the governments and also the industrial players in the regions. And I think this cooperation, world spanning, has to take place, because the resources are all over the world, and the waste that we produce, carbon dioxide, is going out into the entire world. So we should not stop at borders. And this alliance is really bringing people and the different players together.
Fabulous. So thank you very much to the panel. I would like to go to questions from the floor. If people could stand up, please, when we come around with the microphone, and please ask your question.
Yeah, thank you for this insightful discussion. I'm Melanie Walter. I just recently started at the University of Oldenburg as a junior research group leader funded by the BMFGR in the field of bioeconomy. But the research project actually started as a startup idea in the field of the commodities, biofuels. And we ran into the problem of like, prototype, money, prototype. So I was thinking, what advice would you give for the people there to still go into that field specifically, and more generally, where Germany and Australia can learn in that regard from each other?
Who'd like to take that?
Yeah,
Siobhan first.
Volker, go Volker.
So, well, one thing that is certainly good, which I learned today, is this tax benefit in Australia. That I think Germany has to learn on that, because doing research, that's what's needed to advance. And lots of subsidies spent by actually funding advancements and progress in research, that is much better spent money. That's what I think that Germany can learn. On the other hand, in Germany we do have quite a number of these upscaling plants and pilot plants constructed, not just Germany, also Europe. And I think that I don't know how many of these are in Australia, but not as many, I would believe. So, I mean, we can really learn from each other. And this is very important that we do look at each other, because also each other, we do make mistakes. Like subsidies in biofuels, it's not a good thing. And seeing what others have done, good and bad, yeah, that should be.
And I think, so from my learnings, it's about being really resourceful, particularly early on, and trying to prove as much as you possibly can with as little as you have. And one element of it that you can do without much funding is that market validation side. So getting out there and talking to as many customers as you possibly can. So Eclipse, we did a lot of that as part of our incubation in CSIRO alongside our technology development, because that's one of the most important things, at least, that our lead investor wanted to see. They actually got on the phone and spoke to customers that had said, yes, if this product was available, we would buy it. And that market demand, that market pull was hugely important. And that's how we created Eclipse to start with, was doing a lot of that market validation before we even started tech development. So we didn't spend a cent on actually demonstrating we can make this until we confirmed that there was a market for it.
I think you were challenged to talk to 100 customers before you even started. Yeah, so that's amazing. More questions?
There's actually another important point there, which is because we're on the slope of enlightenment, you have the carcasses of all the other startup companies that fell over on the way, and there's lots and lots of learnings from there. I could spend a lot of time talking about that now. I won't, because we don't have time. But there's an enormous advantage of being able to leapfrog over from other people's lessons there.
Yeah, that smart, fast follower as well. Like, that's been hugely advantageous in being able to do it leaner and more efficiently.
Great. More questions? One down the back. Yep. Oh.
Hi, so my name is Norisumiki from Keio University, Japan. So thank you for the nice talk. So you talk about the importance of the non-diluted funding. So it means, is it better to stay kind of a university to get the funding, or is it better to start the company?
I think there's a push-pull there. I don't think that there's a clear answer either way. There's disadvantages of being in an institution. Things do move a little bit more slowly than when you're a startup and you have full agency over how you're spending the funding. But I think non-dilutive plays a really important role regardless, and feel very fortunate being in Australia where we have access to a lot of non-dilutive funding. So it was really important in that initial phase of being able to de-risk it to a point where an investor was comfortable to actually put money in, but then the non-dilutive funding came alongside. So for every dollar that was invested in Eclipse, we have had matched funding from the Australian government through various different programs, plus this R&D tax incentive. So I think a whole debate could be had on, should technology remain in a research organisation, or should it happen outside where it's best for innovation? That's another hour.
Yeah, I've got strong opinions about that, having been both in academia and in industry, and I think it's really important to be able to de-risk a technology within a sector that allows you to do that without enormous cost, and I think universities are great for doing that. But when the rubber hits the road in the commercialisation sphere, it can be very difficult in a university environment. You need to understand that a university exists to train people and to do basic research. And most of them are very bad at doing commercialisation, despite what your tech transfer office will tell you. So there is a stage when you need to grow. And in fact, at QUT, we've developed some really interesting and novel ways of interacting with startup companies that allow them to be based on campus and access our facilities and resources, but to run sort of in parallel without the constraints of needing to operate in the university. I think Eclipse and Edinburgh and other companies have benefited from that approach, but we're sort of at capacity now. We can't take more in that model. So while that model is really great, it's also narrow in that you can't, you're constrained by what you can do within a university.
And also it's
I would like to shortly interfere.
I've got another couple more questions on the go, so I think we might sort of move over here.
Okay.
So there's a question over here.
Yeah, hi. Mary Maxon, Carnegie Science Bioeconomy enthusiast. We've talked about science and technology, and there was regulatory policy was mentioned, and even advanced market commitments were mentioned, and so I'm thinking about the Biotech Act in Europe. Will that help, and will it help anywhere outside of Europe?
Volker, that sounds like a question for you.
So I cannot reply to what you said. No time to do it afterwards, so I disagree in some. It hopefully will help. It is about actually shifting away from the biofuel more to the materials, so chemicals, so producing biomanufacturing things that will keep the carbon dioxide fixed. And so the new bioeconomy strategy of the EU, it's not yet published, but what I've read about it is really going to the right direction. And as I said before, you need to support the market. You have to give the right value to the products so that the industry then can invest and produce them. And I'm very sure that it's the right direction and that the world then will also benefit. But it's a long way, and the fossil resources are just too cheap still.
We've got time for one more really quick question and one more quick answer. Okay, thank you.
Hello, thank you for the discussion here today. My name is Dr. Lior Shaltiel. I'm the CEO of New Oxygen Biologic. We didn't discuss so much on pharmacy here, pharmaceutical, when we are using our exosomes in bioreactors. One of the topics that really bothers me is using a single-use bioreactors that do not drive innovation. If you can elaborate on that.
Well, I have some experience on bioreactors, the development of bioreactors configuration. I think it's a very important field. I see it not in pharmaceutical, but I see it in my field. And I think, I don't know why the established typical CSTR system is so that established to the point that we are not looking at other type of configurations that may be more reliable and that can separate the solid hydraulic retention time from the liquid hydraulic retention time. I think there is an opportunity there for innovation, and I think that's very important.
I think in pharmaceuticals, your industry can afford to use single-use equipment, and they do, and there's a regulatory environment around it as well. So those are challenges that need to be addressed to move on from single-use.
So I know there are lots more questions in the room, but please maybe if you hang around sort of outside and we can happily talk to people after the session. I know we have to keep to time. Look, thank you all very much. Thanks to the panel for your amazing insights. We've heard a lot about the challenges, we've heard the opportunities, but hopefully we've also explored some of the pathways. We've talked about things from around funding, we've talked around the need for social science to integrate, we've talked about tax regulation policy, we've talked about the importance of partnerships. We've talked about the need for regulatory speed to match the speed of technology and innovation. We've talked about social impact. And I'd throw one more thing on the table. I think the other thing we need to scale is boldness and determination. Because if we can scale boldness and determination, we can really scale this industry in a much more rapid and speedy way. So we've got 2 minutes left, which leaves about 30 seconds for each of our panellists to answer one final question, which is, from your point of view, what is the most important next step we must take to break down the walls to scaling biomanufacturing? Claudia, we'll start with you.
Yeah, quantitative analysis of what you are setting out to achieve with your technology using real and defendable data and numbers. And, the framework that we just released looking at that is a really great guide point. I trained ChatGPT to do it for me very effectively. I encourage you to have a look and have a play and learn how to use generative AI to work with you and operate as an extension to your brain, and really be clear on what your pathway to impact is and whether you're going to get there or not.
Sean.
For me, I think it's really that collaboration and partnership piece is absolutely crucial. So I was on a panel recently, and one of the panelists shared an African proverb that really, really stuck with me. And it was, if you want to go fast, go alone. If you want to go far, go together. And for Eclipse, that absolutely underpins what we're about and how we are building for success.
Great. Volker.
So there's so many. I'll just stick to one. That's the technical one. That is get rid of the water in biomanufacturing or reduce the amount of water substantially, because that's adding weight to the cost.
Denise.
For me, it's more understanding, truly listening and understanding industry needs, because there may be some niches where you didn't realize that there was opportunity for providing something to industry. So I think that's my key message.
Fabulous. Look, thank you very much to the panel. It's been a pleasure having you all here today. As I said, please continue the conversation. Thank you very much.